thank you for coming to my talk today. My name is Ian McClerin, and I'm going to be introducing the future of film, as well as an introduction to virtual reality. We're going to have a couple of main focuses, but to get started, we have to make sure that we're in the right page. So today's talk, first I'm going to share why I decided to learn to code, share some themes between film and VR, how VR technology has advanced, how A-Frame works, how Unity works, and why you should learn VR too. So why I decided to learn to code? Because I'm not necessarily a coder by birth. My interest is in filmmaking. I have contributed cinematography to an Emmy-nominated production. I have been to different film festivals that include the Miami Art Basel, AFI Docs, and the New York Film Festival. So this is kind of my main interest and love. I also own a production company that's based in San Francisco and Los Angeles, and we focus on solving challenges at the intersection of storytelling, code, and education. About a year ago, the same time, I ended up filming a video for Code Chrysalis for their marketing department. And in learning about what they were doing, I became more interested in potentially taking this course. Then later we ended up working with Lenovo on some training videos for the Daydream helmet. And so I got more understanding of how all of these pieces fit together and ended up deciding to take a 3-month sabbatical to learn to code. That's what brings me here today. I decided to learn to code, but how is it relevant to filmmaking? Well, right now jobs are changing. How many of you own the whole Adobe suite? Maybe if you work in Photoshop or InDesign or Premiere, you have had to purchase more programs and pay for them routinely. There's examples for editors. Avid, if you learn Premiere, you may also have to learn another nonlinear editing software. So jobs in Hollywood are beginning to depend on technologies, which aren't just limited to cameras themselves, but what editing platforms. And then if you've ever worked with Nuke or maybe Flame, you're working with a system that could be upwards of $20,000, and now that becomes like the obstacle is, do you have access to these resources? Old models are no longer working. So the 90s in America saw an independent film movement. Cheaper equipment meant that there was more accessibility. So new films ended up coming out. And as a result, studios have since adapted, and these thresholds are starting to shrink. They've created their own branches to be able to cash in on this idea of the indie film. So if you have a story and you know your audience and you have a camera, you may be able to make a film and have it seen by other people. So there's never been a better time to be a filmmaker. Distribution, though, now is very unpredictable. Those of you who knew Blockbuster, which was very popular in the US, used to rent VHS cassettes. All of this is beginning to change. They banked their whole entire franchise's philosophy on the fact that people want to have an actual interaction with someone about what movies they might want to see next. And of course they fell by the wayside when Netflix came out of nowhere and ended up just sending at first just DVDs through the mail, but then over time started their own streaming service, and then instead of just becoming a distributor, they became a whole production network. So they were able to start producing television shows and films, and so now Hollywood is a little uncertain as to what the thresholds that they used to be the gatekeepers for creating films. All of that has been sort of put on its head. And there's new questions like, can a robot do my job? So there's 2 products here. We have the solo shot, which if you put a remote in your pocket and walk around, the camera's going to follow you. It's not going to be great cinematography, but people are starting to buy these things. Another example is the GoPro editing software. So you shoot a bunch of video, and then it will automatically merge the clips for you in a very, aesthetically pleasing way, maybe. So I would argue that robots aren't necessarily going to take over your job, but we're figuring out ways to leverage them, as we just saw in music AI if you were in the last set. A big thing that affects me is how much are my services work. As a filmmaker, you have to invest in your own equipment, in your own editing software. But I think the better question is whether your services are future-proof. So my parents had a business. How many people know what this is? It's a slide projector. Yes, we have some. So a long time ago, back in the 80s and really early 90s, if I was giving this presentation, I would have already made all of my slides in advance and put them in this carousel and through the whole entire thing. So that was my parents' business. And in a matter of a couple of years, something called PowerPoint came along. And when that came out, equipment that my parents had invested in, some $11,000, like in the early 90s, which is an exorbitant amount of money, was enough to make someone go bankrupt as soon as your service was no longer valuable. So I, as a filmmaker, want to be able to stay ahead of the curve because there's all of these things that are pushing against me. So I want to expand how I tell stories in a couple different ways. Is through, obviously, through virtual reality. I'm assuming that most of you know, but when you put on a headset and you're in a new environment, that is considered virtual reality. Augmented reality has to do with the fact that your natural world can be changed by holding up maybe a phone or interacting with something in the real world. I don't have to put on glasses necessarily to see it, though there are peripherals that are being made to be able to allocate for that. But I want to be able to get somewhere in the center between augmented reality, virtual reality, 360. I want to change how stories are told. So one of the things that I ended up doing was living for a month in the petrified forest. In the forest of Arizona, there's this great place that used to be where Costa Rica was over, 100,000 years ago. And so now it's a desert. Of course, climate change has affected the way that this environment looks. In an artist residency, which I would recommend all of you participate at some point, you can live in another part of the world or in an environment like a national park in America and create work that has to do with that space. And so you have free access to places that other people wouldn't necessarily be able to visit. So that actually meant that I got to see environments that people, maybe like 100 people have been able to set foot on. So I definitely recommend looking into them if you have them. We ended up taking a 360 camera out and capturing all of these different environments. And if you're interested, I brought a demo so that some of you, if you've never been to a desert, because here we are in Japan, you can have the first opportunity to experience it in VR. So one of the things that we were doing was trying to figure out a couple things. How do we allow people the opportunity to visit a harsh landscape? That could be the temperatures. Physically, there are no paved walkways. So it can be very dangerous to be able to get into some of these areas. Another thing is that we've been trying to protect over time people's ability to vandalize certain areas. I'm about to share with you a petroglyph, but it's our oldest graffiti. Essentially, people from hundreds of thousands of years ago left their marks on different parts of the world. And we've tried very hard to salvage those and protect them. And so I ended up creating an app, which you can visit right now. If you were to pull up your phone and type in this application, you would suddenly be in a 360 environment. So, because of my placement, I can't necessarily show you on my phone, so I'll show you here. This is going to reflect the 360 environment. As we pull around, you can see, obviously I am, in fact, in the petrified forest. So this is called Newspaper Rock. And when I click on this area, I can leave a glyph. So all of these different images were left hundreds of thousands of years ago, and I wanted to give people an opportunity to maybe leave their own mark on this environment. So one of the things that we were trying to figure out is, how do you take a 360 space and then add a plane to it? And there's a couple of examples. I built this in A-frame. Has anyone worked with A-frame before? It's very interesting. Even in the browser, I can pull up just by hitting Control-Option-I. I can open up an inspector, and I'll share what that means more in just a second. But I actually have the ability to affect a lot of the environment in real time. I could add lights, I can add spheres, and then of course go back to this world again. It's very interesting because this is all done in HTML. This is all built within the browser. So the threshold of being able to do VR is now so much more accessible than it ever was. So a couple of things that I want to share with you. Being a filmmaker, my background, I'm interested in what some of the themes are between the two of these. And so here's some things that I'm seeing. basically, whenever you're creating a visual mood, there's a couple of things. Position, where are you going to put the camera? Light, what is actually being exposed in the frame? And then the environment. Where physically are we? And that's a little bit different between film and VR. In film, there was this very early Soviet who ended up coming up with this idea of montage. He, instead of just filming individual things, he tried to juxtapose these images together. And so he takes an image of a man, and then he ends up placing it beside a bowl of soup, and then cuts back to the man. And so all of these people in the very early days of filmmaking were trying to understand, okay, how do we create connections subconsciously? And the students realized when you put these images together, even though it's the same face here and here, he looks like he's hungry. If you end up switching it, maybe show an image of a little girl in a casket, you're going to think, oh, that's his daughter. Oh, he is sad. Or in the last frame, he's looking at a woman who's reclining. Maybe that's his girlfriend. Maybe that's someone he's interested in being with. And now he looks lustful, maybe? So there were all of these things that we were beginning to play with. It wasn't so much about what we were filming, but how we were manipulating people to understand what they were observing. In VR, it's a little different because instead of having multiple shots, you have one shot, and that person has access to look in any particular direction. In this example, we see two people and they're filming something, but if we turn the frame, if I start off looking at two people, it's going to be more interesting to realize, oh, there's something behind me that obviously I need to pay attention to. So you don't necessarily tell people immediately what you want them to see as you do in film. You have to be ready in VR to let people naturally understand their environment. Another thing is that in VR, we're not working so much with a flat space, we're working with depth. So that means that there's a Z-axis. So now we're dealing with actual environment. Instead of something being flat, we're working in 3 dimensions. So this means that there's a couple of different things we can play with. Is the character we start out in this VR world a turtle? Are you this tall? Are you at the bottom? Where do we put the camera so that the audience can begin to feel like they are a part of this scene? Which makes me draw some conclusions that VR is a little bit more like theater than it's like film. Because in theater, you're usually watching something play out all in one scene, and the only thing that we have to divide this are entrances and exits and being distracted. Anyone who's ever been to a promenade theater where everything is happening around you gives you an indication of what VR is and the way we have to think about it. Lighting in film can either be natural or artificial. You can bring it in, you can use the actual daylight. There are different ways that we get beautiful shots. This is an example from Amelie, a wonderful film, using the 3-point lighting system. Essentially, you have all of these lights that are outside of frame. Every movie that you're watching, if you take one step back from what the camera sees, there's 100 people that are hunched over trying to understand, like, how can this be the most beautiful shot? It requires a team of people for that reason. Also means that you have some dynamic range, but it also means that you're limited by space. So unless you're working on a big sound stage, if we were to shoot a scene in here, it can get very cramped. The more lights you bring in, the hotter it gets. There's a lot of things that you have to be thinking about, which include making your actors happy, if you like actors. Another thing is lighting in VR. So it's a little bit different. As we can see in this GIF, I can move this camera asset around, which I'll explain in detail later. As you can see in real time, it's changing what that looks like. You can change the lights to ambient, directional, or spot, which just means how much light is being emitted. This also means that you have infinite space to work in. You're not limited by anything. You can easily change a light, whereas in film, if you have someone set up a light and you don't like where it is, because it doesn't look right, you have to get that person to move it, which actually takes a lot more time than you think. And on a set, time is money. So in VR, you kind of have a little bit more time to be a perfectionist if you're racing against a clock. Environment is film I was talking about earlier. Look at it. All these people are watching, like these 3 people in front of the screen. It's a very tight environment. And it concentrates 2 primary senses. Whenever you go into a theater, really, the only senses that are utilized are what you see and what you hear. Whatever's in that frame is what exists to the audience. And the filmmaker has the ability to guide that person's eye. It's usually monoscopic, which means that you are seeing a flat space as opposed to 3D glasses. If you've ever gone to a 3D film, monoscopic just means it's one scene, as opposed to stereoscopic, which is how we naturally see with two eyes. We have two cameras at all times. The other thing is that in film, you can watch it anywhere. It's never been so easy to watch a film, even on your cell phone. Environment in VR is a little different because you get to define the limits of that space. How far is something going to reach? Your audience chooses what they focus on. So as a filmmaker, you are now sacrificing people's own ability to kind of wander off if they want to. So you have to be thinking about how to grab their attention. You can integrate haptics, which is a fancy word of environmental stimulus. So if you are in a room and it's very cold because we're watching a VR film of maybe ice in the polar hemisphere, then you're trying to integrate maybe wind or all of these other things that will make someone feel like they're more in a space. Because when you put on a helmet, you're an audience of one. And so everything that you're feeling can be affected by your outside circumstances. And it can be monoscopic or stereoscopic. So you can see 3D depth with these goggles. It doesn't just have to be the same way we see films. Right now, the distribution for this is pretty limited, but it's beginning to grow in an amazing way. So some of the biggest differences is, of course, as I mentioned, you have one take versus many takes in film. You're doing a lot of editing. And then the other thing that maybe you're not thinking about is gravity and collisions have mathematical values. So in A-frame and Unity, you're dealing with static or impenetrable spaces and objects. And then dynamic allows them to have more gravity. So now we're having to, in these environments, take into account how these objects interact with one another. They don't naturally know what to do when you're building. So how is VR technology evolving? Well, first we had some motion-based and real-time data collectors. Kinect, which came with the Xbox, is now being used in hospitals to be able to manipulate X-rays in 3 dimensions. Google Glass, which was considered a failure, is still used in some production warehouses so that people can get real-time data as they're working. Other examples include the Oculus or the PlayStation VR, which were connected to a PC or a console, so you needed an external device to be able to run these. And now, one example is the Google Daydream, which I have right here, as well as the Oculus Go, which came out last year, which was affordable wearable headsets. Essentially, now people didn't have to be connected to anything in particular to be able to run. They run by themselves. And now we're trying to aim for that all-in-one experience in a couple different ways through examples like Magic Leap, which are going to be AR glasses that you can wear and interact with environments, as well as the Oculus Quest. So now you have the ability to do more in a virtual reality space. So it's never been a better time to start building. And some ways that you can approach it, you have, of course, Unreal Engine. We have Unity, which runs in C#, and then we have a really great JavaScript framework that was built starting with WebGL, and then was built into 3JS, and 3JS is interacting with A-frame as well as React 360. Today we're going to talk about Unity and A-frame specifically. For Unity, it's a freemium download, so if you were to go online, you could very easily start building today. Scripts require a little bit of C# knowledge, but there's a lot of tutorials. It has a very robust interface, but if sometimes UI kind of trips you out and you need something a little bit more simple, an example would be A-frame, which can be built in your browser. There are user-generated scripts that allow all sorts of different opportunities to change your environment. And it also has an inspector console that instantly pops up, even in your HTML browser. So let's get started with A-frame. First off, it begins with a minified script that you can include inside the very top of your HTML body, which basically requires your A-frame. And then you end up including different things in your scene. You have a camera, maybe you have an entity that's attached to that camera, and then you include all of these assets. What are the three-dimensional objects that exist in this space? When you're looking at it, you have a couple of different options. You can always bring it up using this command, but you start off with assets or entities. I want you all to think about it as what is in my frame? What does it look like? What is the hierarchy of different objects that I can manipulate? All of that exists on this side. And then over here, we have all the components. And components I want you to think about as how do you end up changing what your asset looks like? What color is it? What texture might it have? Are there lights attached to it? Does it have gravity? Can you pass through it? Or is it a static object? Then you have, of course, the scene viewer, which is how you're able to manipulate the space. And up here, which I think is one of the best places to start for someone who doesn't know what they're doing, you can simply export any one of these hosted A-frame projects and be able to manipulate, see how it's built as an HTML file, and then also start building and serving it online as well. So you can begin to play with stuff even if you don't know how it's built. So here's a couple of A-frame examples that I want to show you. So one of them, of course, I had mentioned earlier how the physics works. Actually, I'll do it in this one. So this is Glitch, which basically allows you the opportunity to run a project in your browser anywhere someone has access to it. If you have difficulty deploying, you're unfamiliar with Heroku, this is instant deployment. So anyone can visit a link and then see your project. This is one of the examples that they had built. But as you can see here, all the assets that are in the scene, if you're familiar with Photoshop, like there's an eye, I can make it appear or disappear. I can click on this 3D object and I can say it is dynamic. And now I'm changing the component to have a dynamic body. When I do so, that means when I run this scene, it's going to have gravity. Oh, there it goes. It's gone. So if I bring it back up, because of course this project doesn't necessarily do any quick saves, and I make the ground, I'm now clicked on the ground, and if you're confused, there's the grid. I can change this to static, and these are vocabulary that work between both Unity and A-frame. When I go back to scene, it's going to hit the ground. It's not as graceful, but of course, as you can see, it now knows how to interact with one another. Another example, I shared with you the graffiti project before, but you have the ability to manipulate it in your browser. Something else that I built, this is another scene, and as you can see, it looks like right now we're in the desert, and there's a little bit of rain that's been added to this environment that I've done manually. If I wanted to change that, as you can see over here, I've added this entity that is my weather particle. So a particle is any kind of three-dimensional image that ends up affecting your environment. Here I have a particle system, and I can change this to snow. And when I go back to my scene, now it's a little bit different. This kind of reminds me of like Windows 95, like a screensaver. But I mean, it's interesting I was able to do that instantaneously, simply because I added another minified script that says I want to have different options to play with. I want rain, I want to be able to add snow if I want, as well as dust. And then of course, like you can change any one of these components, add additional ones, another camera maybe, some controls, fog. So you begin to think about VR as an opportunity to create an atmosphere. Another example that I have down here, at the very bottom, if you were to visit this page, if it lets me visit this page, is an example of watching a movie in 3D space. Let me turn the sound off. But if I click in this environment, it's going to begin to play, and I have the ability to walk towards this screen. It's running a little bit lagging because I have 4 different projects playing in here. But it's a 360 space, powered by Vimeo. I have the opportunity to drag a Vimeo asset or link, a URL, and then instantly begin playing it in a 360 space. I haven't been able to figure this out when it comes to an environment like this. I had to manually insert this video file. But A-frame is trying to keep up, and it wants to be able to include more opportunities in the future. So it's constantly being built upon. So what are some pros to it? If you can't code, there's no problem with that. There's obviously some easy HTML that you can play with, that you can begin building immediately. Custom libraries also include working with Blender. If anyone's ever worked with creating Blender, now you can integrate some really much more robust 3D packages and run it through a JSON and then have it appear in A-frame. You have the ability to deploy via glitch, which I shared earlier. So if you had a project you're working on, you can send someone that link and then they can begin playing with it in their browser or experiencing it. There's a community of people that are excited about it. So Slack, of course, as well as Reddit pages and a lot of other different searches have been made available. And web VR accessibility is beginning to get a lot better, as well as the fact that HTML means that people don't have to download the apps. So this is the big change now, is that there's an evolution for VR that's happening. We start off with WebGL, which was built back in 2006. We've been trying to figure out how to fit 2D and 3D in someone's browser. And we just finally were able to get universal browser support just 2 years ago. And now it's starting to move faster. WebVR, which is what you were just seeing, if you bring up my app, you have the opportunity to use even your smartphone to be able to look in a VR environment. And that has only been in development between 2014 and 2017. It's still a little experimental, but these are signs that there is an adoption that is quickly taking place. And then of course WebXR, which just was recently announced, which will allow people to use AR in their browser. So you could hold up a phone on maybe a QR code, but now there's an animation that's playing along with it. All of that to happen on your phone without you really sending too much data is amazing, which means that things like this are going to have to compete. Because ultimately any application that can be written in JavaScript will eventually be written in JavaScript. That's what we're running into. It's the language of the browser, so the ability to leverage VR and AR in your browser will become even more competitive as time goes on. Here's some things that I didn't like about it, is that it abstracts away from 3.js. So if you're trying to learn 3.js, which is a lot more of a complicated language, A-Frame isn't going to help you understand a lot of the necessary basics with coding. They both require manipulating the DOM directly. The project that I was sharing with you earlier, I ended up making it so that all of the glyphs that were being posted on this frame were attached to React so that I can manage that state. This also means that there's potentially some custom code that you'll have to write to be able to have it interact with other VR helmets. And so as a result, there's a lot of things that you might not be thinking about that are going to mess with the accessibility for other people. Some other things, Glitchy Inspector can destroy entities. If I was to begin playing with lighting, for example, and moving a light around in 3D space, it may destroy all of the other lighting elements that I've created. I don't know why it does that, but it's something to be aware of, is that sometimes the project can get away from you if you're not paying attention to your assets. Also, I showed you earlier how to export a image really easily, or your whole HTML code, but it also ends up putting in some unnecessary. This added bit isn't necessary. As you can see, this 4 is already being utilized in the particle system. So when I wanted to add rain to my scene and then export this out, it actually ended up adding additional code, and there was no reason for that. So if you're a purist and you want it simple, it's going to make it more complicated and add some extra code unnecessary. And then another thing is that there was an exciting prospect that, which was known as AR.js. Basically, this guy was figuring out on his own, how do I create AR in my phone? And this is about 1.5 years ago, where essentially here's a portal that this person is about to walk through. And then everything is, of course, being image tracked, which is pretty incredible. And he was building this project all by himself, and then recently found that either it was overwhelming, but he's completely disappeared. He hasn't responded to anything. So people build libraries for this, but then they don't end up adding anything. So that would be something I'd be worried about in learning A-Frame. Though, as I said earlier, we're beginning to play with WebXR, which will allow people to then manipulate spaces in their browser just like this. So yeah, infinite possibilities. Let's make this big again. So getting started with Unity. when I hit this, it doesn't get bigger. So I'm going to click to the next one, and then try again. Alright, so this is what my browser looks like. So Unity, getting started. Very easy. All you have to do is download it. You can manipulate variables, functions, and classes. And classes are built on something known as scripts. So in C#, which is a primary language that you can use Unity for, you're defining the behavior of every object. So instead of A-frame, where all of these objects kind of already knew what to do in some cases, you could add components to them, you have to actually write this code to be able to do so. So you require Unity at the top of your C# script, and then you end up declaring what your class is. That class name has to match. And then you have a couple of different functions you can play with. You have a start, which will begin running immediately, and everything that you need to have run immediately. Like, for example, I want an enemy to already have ammunition of a set amount. Then you update that with a bunch of different series of functions where you add all of your components. You add how things are going to react to one another. So in the inspector, as you saw earlier, you had the ability to you have the scene viewer, which allows you to be able to see what your 3D scene looks like. Then you have the game viewer, which allows you the opportunity to actually play through the scene in real time. You have a scene assets folder, which is every single asset that you will be playing with. And then you have a project folder, which is your hierarchy of different files that you've imported. And then you have an inspector, which is where you start getting into the individual nuts and bolts of every single component, every object that you're including. And in this yellow area is where you'd actually attribute extra scripts or maybe variables if you want to change a certain aspect of a graphic. Let me explain what I mean by that. So my game, I created this in 5 hours. So when I play this, I will have the ability to maneuver through this environment. And if I collect all of these squares, which I had to write a script that says this square is going to be able to turn on its corner and spin around. If I collect all of them, if I knock into that, it's going to fall down. I win. I've somehow counted everything. This has some crazy physics that I never figured out, so it keeps breakdancing. And this, just because it's fun, explodes when you run into it. It's because, like, as soon as you're working on something, you hope that you can destroy it at some point. So the more you bump into it, the more it explodes. I'm not going to do it too much more. Because, as you can see, everything went orange, because if I'm to augment anything while I'm testing it, it will go back to the way it was before. So if I wanted to, for example, change the speed of my player, which I declared as an outside variable. If I want to change that so that it goes even faster and then begin playing it here, this ball's going to move twice as fast as it did before. And that small functionality to be able to change that is something that I manually had to write inside my script. So if I end up clicking on my script for move player, you can see that there's quite a lot going on. Because you have to say, if you go straight up and down, you're going to move along this plane like so, or if you're going to go left and right, as well as the fact that you have to declare at the top what the speed is as a public variable. And if anyone's ever worked with C# before, it's a little different than JavaScript. Though JavaScript is supported in Unity. So I have a lot of other possibilities in this environment if I wanted to have this explode, or say, like, maybe I want to move something. I can move my environment around. Very similar as A-frame, you get used to this environment. This is your vector 3, which allows you to move. I have one object selected. I should probably go with something that I can move in other crazy directions. Everything is being done naturally here. If I hit play, because this doesn't have gravity, it's not going to fall down. It's going to keep floating in space, which you actually can't see because I moved it too high. But you get instant results, which I really appreciate about it, and what I like working with it, even though it's at first a little overwhelming. So going back to our example. Okay. Unity Pros. It's an in-demand skill set. You can teach yourself. There are tons of tutorials that are online. In San Francisco, you can get a job starting out anywhere between 80 and 120 grand, $100,000 out of the gate, which is pretty ridiculous for even just some cursory knowledge, because it's getting a lot more demand in the industries, both gaming as well as VR and film. You can export to more than just the internet. PS4, Facebook, WebGL, Xbox, as well as, of course, making a standalone application. So you can share this in a variety of ways. Unity Store allows you to import different presets, so you could, anything that anyone's created, you could begin working with. And then you have also the ability to change any of the prefabricated objects that you've made, which is a lot more difficult to do in A-frame. You also have the ability to animate, and you can get salary for that skill set. Some things that may be detracting is that there is quite a learning curve. If you haven't learned C# or some of the JavaScript fundamentals, which helps you understand C#, it's going to be a little bit difficult. As I mentioned earlier, Unity is compatible with Boo, which is a non-popular Python script, as well as JavaScript. JavaScript isn't exactly the same when you're utilizing it inside Unity. So if you get overwhelmed by complex user interfaces, it might be a little bit of a difficult learning curve. And you need some reliable computer specs because it does take a lot of energy. So something I want to talk about is why you should learn VR as well. Well, first and foremost, it's still incredibly experimental. We don't know what mainstream adoption looks like, but right now there's a lot more involvement, making it a lot easier for people to be able to pick this up and begin playing with it within your browser. I've worked in schools before, and kids were bragging about learning on Python in the 6th grade. This was several years ago at this point. So the kind of workforce that the current generations are being prepared for are perfectly aligned with this. There'll always be competition. But that also means it's a lot easier. Just in the way that cameras have made it a lot easier for people to become filmmakers, there's no reason that you can't start playing with this yourself. So there's a couple things that we've been learning so far. Haptics. So right now, this is me in the airport being flung around in a really dizzying pace. This was not fun. I felt really nauseous, which is something that we have to keep in mind. So even though the wind is blowing on my face and I'm being moved around and the sound of like rushing wind and music are playing in my ears, I'm feeling a little nauseous because my horizon line is changing. If you were to make a VR experience, you have the ability to go really fast in one direction, but you cannot change what the horizon looks like or people get nauseous. If you have vertigo, you know what I'm talking about. Spatial sound is now a little bit easier. So the ability to record several different directions where when you move your head, you have the sound actually mapped to that area. You can buy a Zoom recorder, which allows you, it's about 180 USD, where you can go out and begin filming environments and recording natural sound that will integrate flawlessly within your experience. Transitions, I mentioned earlier about theater. A couple things that we have learned is that if you want to be able to change between scenes, really good practices include fade-ins and fade-outs, just as all the lights come on and go out when you're in a theater production, as well as sound. You can use sound as a way that you can move people through time and through space. So even though we're growing technically, I still think that this is where we are. We're in the very beginning of film. So a long time ago, right before the turn of the century, 1893, there's a guy named Edward Muybridge, and on a bet, someone asked him, do you think that all 4 hooves of this horse leave the ground? And he's like, I have a way to test for that. I'm going to set up several cameras and I'm going to record it. And little did he know that he would end up creating the birth of cinema. He started filming all sorts of regular everyday objects and things and people moving to get a better understanding. So he's beginning to play, which led to all of these other things. Let's take it out of a sterile environment. Let's start filming people dancing. Cats, we've always been obsessed with them. Let's have them box. Let's film someone sneezing. These became like things that people spent money on to experience, even though they're 10 seconds long. This was like, ugh, get shivers. Like, you're gonna go hang out at the carnival. You were watching real life being projected. Which of course leads to one of the most famous examples. At one point, a train was being shown coming into a theater, and people leapt out of their seats, allegedly. This is apocryphal, but people leapt out of their seats because they were so nervous that the train was going to hit them. Of course, now we see this and we're like, no, that's not going to happen. But I think in the same way, when you put on a VR helmet, you're like, wow, like everything impresses you still. But we're starting to play with what that looks like. As we can see in the Trick Eye Museum in Seoul, this is my partner being attacked by a snake and by 2 different sharks. Now, this says that it's, of course, a museum of AR, but it's really just a gimmick. We're still trying to make things that inspire people to film, but that's about the limitation of it. There's nothing that you're really getting out of this experience. It's, I think, hollow. It feels a little cheap. Other examples is that we're placing new art over old art forms and then telling the audience what we want them to feel. Now, there's some great examples that exist that are absolutely mesmerizing, but at the same time, we haven't begun to figure out what and how we should be playing with space. This brings me to Team Lab, which, if you haven't been, is worth every dollar. This experience right here is one of the smallest out-of-the-way scenes, but you go and you get tea, and it's not the experience that while you're waiting for your tea to cool down, a flower starts to grow inside of it. You have no idea how it's happening, but when you move that glass after that flower is done blooming, it just starts scattering out everywhere, as you can obviously see. So someone's beginning to think about, how do we take our environment and have it not be the conversation piece, but it is something that is happening around us, just as real life does. How do we create things that make us feel something? I'm not being told what to feel when this happens. I'm in awe, but it's not the point of the experience of just simply having tea or watching something bloom. We're beginning to move towards inferences. We're beginning to move towards, how does this make me feel? And Hollywood is starting to take interest. We're past the proof of concept stage. Spheres, which was released last year at Sundance, sold for over $1 million. Someone put a price tag on what a VR experience should feel like. And Hollywood doesn't take chances lightly. So this was one of the very first examples. This is signaling a change. Do you want to visit outer space? Hollywood does. So if you begin thinking in terms of this, you will likewise also have the opportunity to maybe create something important. An important takeaway is that I think that those who put in the time and struggle as early adopters will help define its impact. Otherwise, we're going to see more trick eye, more bullshit. And this is the most important thing, is I want to let you know that I think that experts are often just early adopters. All of you are experts if you start learning today. Thank you for your time. If you have any questions, feel free to speak with me.